Good morning. Welcome to Lionheart Academy. We're continuing our trigonometry lesson. Today is the lesson 22. Now today we're going to be moving on to the next topic, major topic in our lessons, so in geometry lessons. It is called, we're going to try to start discussing the graphs of trig functions. Alright, so let's go ahead and revisit this is a unit circle again. We're going to try to develop the graphs of unit circles. We're going to try to develop the graphs of trig function starting with sine, cosine function, starting with the unit circle. Okay, so we have the x, r, y coordinate here. Okay, and we're going to have our origin here, and this is because this is a unit circle, so this order pair is going to be starting with 1, 0, and this will be 0, 1. Alright, so let's just look at this first quadrant and let's see how we can take a look at what does it mean to graph a function with y equal to sine x or y equal to sine t. Alright, so let's go ahead and draw radius. Okay, just any kind of radius here. Alright, as on the order pair, as you can see on the radius, we always have an x coordinate and y coordinate. And this x coordinate and y coordinate corresponds to the distance from this point. The x coordinate corresponds to the distance from this point to the y axis. So that's why we usually draw it here. Okay, using a green segment here. As you can see, that green segment represents the x value, and the the red segment here I drew represents the y value. So I'm going to label that a little bit. Okay, x, and I'm going to label this y. Now the radius here is 1. Okay, so the radius is 1. The angle theta is, as usual, is this angle right here, the angle formed between the terminal side and the initial side, the positive x-axis. Now, in the unit circle, as we can see, the two segments here, the x segment is the adjacent leg of theta. If you look at this right triangle, this is the right triangle. So x over 1 is this cosine of theta. And so cosine of theta is equal to x. The x coordinate is representing cosine theta. So let's go ahead and write cosine theta here. I'm going to write it in green here. X equal to cosine theta. And y, the opposite leg, divided by 1 is corresponding to sine of theta. So those two segments, they represent the measurements of the function. Okay, cosine theta and then sine theta. These two segments physically represents those when you have a unit circle. Alright, and so sine of theta is equal to the y segment. So what it means is this point, okay, x and y, what we can say is we can actually write it as cosine of theta and sine of theta. So we have done this before in the unit circle. Now, what does that help us to do with helping us graphing the function? How does that help us graphing the function? So if you want to graph, we have to use a separate variable here. So if you want to graph the value of sine function as theta goes from 0 all the way to, well, that's another thing. Okay, so we're going to use theta, but we are not going to use degree because degrees is going to be a little bit hard to graph on the real number axis. What's the better way to graph theta is going to be using a real number representation, which is the radian measure. So from 0 here is the radian measure is 0 for x, and here the radian measure is going to be pi over 2, and then if you keep going here, the radian measure will be pi for 180 degrees. If I extend this down here, this will be 3 pi over 2. Okay, so and then if we come back here to the beginning point, it's going to be 2 pi, and then it will keep going. So the measurements is going to go from 0, 1, well, for sine it's going to go from 0 all the way to 1. And if you remember, the progressions, it will go through 30 degrees, which is pi over pi over 6, and 45 degrees pi over 4, and 60 degrees pi over 3, and then it will be pi over 2, and then it will go through several measures of different measures, and we can see what kind of progression it has, right? So let's go ahead and try to graph those kind of values and see how it goes. Okay, let's take a look at how these things will develop. So here we have a simplified version of our unit circle here. As you can see, the order pair. We start with 0. Okay, this is pi over 2, and this is pi. This is 3 pi over 2. Now, why don't we one more time? Let me explain the reason why don't we use angles. Because radians are real numbers, so we can graph in our real number axis. Now, of course, I could label this axis using degrees, but that is not very convenient, because the degrees will go up very high, and then the degrees are not real numbers, so we have to use real numbers 0, and well, of course, this is real number 3.14, approximately 3.14, 2 pi is approximately 6.28. So when we graph the axis for our angle, then we will able to use real numbers to graph it. Okay, so you will come to see what will happen a little bit later. Okay, well, this is not pi over 3, it's pi over 6. It's 30 degrees, pi over 4, 45 degrees, and pi over 6 is 60 degrees. Okay, so let's go ahead and take a look at the graph of sine theta. So let's say we are going to graph sine theta, or y equal to sine theta. Well, this is still the vertical axis. This is the horizontal axis, but we're going to usually use x. Well, we're going to say x equal to theta. Okay, in this case, and then y is equal to sine theta. All right. So as theta progresses from 0. So first of all, okay, we can see that there are two coordinates here, right? On this unit circle here, we have two coordinates. The first coordinate represents x, the second coordinate represents y, but also remember we just talked about the first coordinate represents cosine of theta, the second coordinate represents sine of theta. So if I want to graph sine of theta now, I'm going to start with 0, right? So sine of 0, here is 0. Sine of 0, when theta is equal to 0, sine is equal to 0. So I put 0 here. Okay. Alright, this is pi over 4, halfway pi over 2, and then a little bit before pi over 4 is pi over 6, a little bit after pi over 4 is pi over 3. Okay. Alright, so then let's go to the next point. Next point is that when theta becomes pi over 6, so I progress to pi over 6, the final value of sine theta is 1/2, so I go up to 1/2. And then it continues through at pi over 4 is square root 2 over 2. Now, square root 2 over 2 is about 0.707. So this is 0.5, right? So it's about here. Okay. 0.707, let me put a point, and then we keep going to pi over 6 is square root 3 over 2, that's 0.866. 0.866, so I would say about here, almost to 0.9, and then 1/2 at the pi over 2 sine value. We remember sine values to look at the second coordinate. Sine value becomes 1, so it becomes like this. So as you can see, as theta progresses from 0 to pi over 2, the value of sine gradually goes up like this in not a linear format, but as a curve, in a curvature format. Okay. So as we go through the second quadrant, okay, coming from pi over 2 to pi, the values goes down, but the value, if you remember, these values, they are actually equal and opposite in the x values. Okay, so only the x value changes, but the y value doesn't change. If you have your unit circle, I'm sorry, I'm writing a little sloppy here. If you have your unit circle in front of you, you can refer to those values. And this angle, this is 2 pi over 3. This is 3 pi over 4, and this is 5 pi over 6. But basically, they are the same spaces over here. This is 3 pi over 4, and this is 2 pi over 3. That's 5 pi over 6. So the values will go ahead and come back down. It will be the same value as we have previously graphed, and at pi it will go back to 0. So I know this doesn't look too good here. Let me go ahead and try to make it a little more accurate here. Yeah. Okay, that's a little better. Okay, so if we go and connect the dots using a smooth curve, because we know each of this is a progression, so the first part of the sine function, oops, I do apologize, it's kind of hard to draw free-handed like this. So it will look like this from the first part of the sine graph. And as he progresses down here, as you can remember, sine values will become negative. Here sine value will stay negative. Alright, but the negative values eventually at 3 pi over 2, sine will go down to -1, and then at 2 pi, here is 0 and 2 pi, sine will become back to 0. Okay, and so this is another. At the middle point, we also know the midpoint, it will be -1/2, and then this one will, not at the midpoint, but I mean the first one, it will be -1/2 right here, and then it will be -7, and then -8.6. This will be -8.6, -7, and -1/2. So this will continue to develop through like this, go to the minimum point, and then come back up. Okay, I missed a few points here. So what happens is, well, what happens after 2 pi? Well, if you look at unit circle, after 2 pi, we continue, we repeat, the values start to repeat. You start going back to pi over 6, pi over 4, pi over 3, pi over 6, okay, this is pi over 3, I'm sorry. Start going back to pi over 6, pi over 4, and pi over 3, so this will repeat. This value will start repeating itself. And then which makes this function, sine value function, a periodic function. So after 2 pi, we basically will start over again, but you basically can imagine, take this whole function value and start drawing again over here. So the function will keep going. Okay, so let's draw an arrow. This will keep going. And what about before 0? Before 0, you will do the same thing. So a sine value function, the graph of sine function is periodic because it repeats itself. The whole function is periodic. It repeats the value repeats in a certain time, certain period. So that's why we only need to graph the first period. This is called the first period. Later on, we're going to discuss how the proper. There are different names and different things that we're going to talk about this function. Alright, so hold on, let's. And now there are other animations online that will allow you to see how this actually progresses as the y value changes. Now, as you can see, the y value is always this segment that represents sine of theta. So this segment really, so this sine segment, the red segment here represents sine segment. And so as the sine segment progresses, as you can see, as the angle goes up, the sine segment increases, and eventually the maximum value of sine will be 1 at pi over 2. Then you start to decrease. So as you can see, the graph follows as you go from pi over 2 to pi, the sine values start to decrease. When you get to pi, there's no y value anymore, so it's back to 0. Then the y value goes down towards negative, so that's what it did. It increases towards decreases towards -1, and then at 3 pi over 2, that reaches the minimum value, and then it swings back up. So this graph gives you an idea of what's the change, how sine value is changing as your angle progresses, as your x-coordinate, as your time or angle increases from 0 to 2 pi and beyond that. So this is very important for us to understand the graph in order to understand the sine function and the other applications of it. Alright, well, today let's go ahead and stop right here. We'll go ahead and talk about the other graphs and this cosine graphs next time we come back in our next lesson. Alright, and we hope to see you next time, and please remember to leave any comments, questions that you may have in the comment section. Alright, and we hope to see you in the next lesson.